Alright, so today we're reviewing Unit 10, which is going to be redox reactions for chemistry. And yeah, let's get right into it. So here we have a voltaic cell, which has zinc on the left side, the anode, and then it has iron on the right side as the cathode. And it says the cell and the unbalanced ionic equation representing the reaction that occurs in the cell are as follows, shown below. Number 1 says explain in terms of zinc atoms and zinc ions why the mass of the zinc electrode decreases as the cell operates. So this is the electrode right here. So what happens is, because this is the anode, zinc is going to be losing electrons, right? So part of this is going to just like fly off as electrons come off, and so the mass actually decreases. And you can see this in the equation, right? You have zinc solid going to zinc plus 2. Now this plus 2 means that it's lost 2 electrons. And so the mass of the zinc electrode decreases as it operates because it is oxidized. Alright, number 2, identify the subatomic particle that flows through the wire as the cell operates. So this is the wire right here that connects the anode and cathode. So what flows through here are the electrons. Now the salt bridge thing, that's where the actual ions will flow, and that just keeps a balance between the two electrodes. But for number 2, that is going to be electrons. Alright, moving on. Number 3, write a balanced half reaction equation for the reduction of the iron ions and iron 3 oxide to iron atoms. Alright, so for this one, we're going to start off with our iron 3, iron plus 3, because it wants us to show the reduction for iron 3 oxide to iron atoms. So we're going to have an addition of 3 electrons, and that is all going to go to iron, one iron atom. So the reason for this is because in these redox reactions, there's going to be a conservation of mass and conservation of charge, right? So the charge on this side, plus 3, on this side is going to be 0. And so we have that negative 3 from those 3 electrons, and so this cancels out and gives up 0. And then we have 1 mole of Fe, 1 mole of Fe, and then electrons mass is negligible. So yeah, there we have it. So number 3, boom. Alright, number 4, identify one metal from the passage that is more active than carbon and one metal from the passage that is less active than carbon. So in this passage here, it says metallic elements are obtained from their ores by reduction. Some metals such as zinc, lead, iron, and copper can be obtained by heating their oxides with carbon. So we can pick from any of these. We can pick zinc, lead, iron, copper, doesn't matter. Alright, so for this one, we can just pick something like zinc. And now for the one that is more active, we can just look below. It says more active metals such as aluminum, magnesium, and sodium cannot be reduced. So let's just pick aluminum here. So yeah, there we have it. Identify the component required for electrolysis of molten NaCl that is missing from the cell diagram. So basically, this is electrolysis, and it can't really operate right now because it's missing something in the middle. And what is that something? Well, it is energy. Right? It needs a power source. And so the answer for this is a battery. Alright, number 6, state in terms of energy why the cell is a voltaic cell. Alright, so it's a voltaic cell because, first off, is there a battery? No. So there is no battery. And so what you want to look for is how energy is created, right? So these electrodes, the redox reactions that they go through, the half reactions that they go through, are producing chemical energy. Chemical energy. And this chemical energy ultimately is going to power this entire system, right? So it's like a circuit of electrons that flow through. And so this chemical energy will go and create electrical energy. And so in this case, because it goes from chemical energy to electrical energy, That's how you know it is a voltaic cell as opposed to something like electrolysis, which requires a battery. So there we go. Number 7, determine the number of moles of aluminum needed to completely react with 9 moles of nickel ions. So we have 2 aluminum, which reacts with 2 moles of aluminum reacts with 3 moles of nitrogen. All right. Oops. So if we have a ratio of, so we have 9 moles of nickel, and so if initially we had 3 moles of nickel, and this gave us 2 moles of aluminum, that is a 3 or 1.5 ratio, right? And so we can do the same thing here. It's just 9 divided by 1.5 equals, and that should give us, boom, 6. All right, number 8, write a balanced half reaction for the oxidation that occurs when the switch is closed. All right, so oxidation means a loss of electrons. So let's see which of these electrodes actually loses electrons. So we can see here the aluminum goes from a neutral charge of 0, and it goes to, looks like +3. And so it is actually losing 3 electrons. And so we know that aluminum, the solid aluminum in the electrode, is being oxidized. And therefore, if we were to write this out, let me do this to the side, we would start off with our 2 aluminum, right? And this is already balanced. And so this would just go to, it's losing electrons. So the electrons would be on the right side. And then our products is right here. So 2 aluminum, and it's a +3 ion. And then we have to add our electrons, right? So if this is 6, this is a +6, we need a -6. And so we need 6 electrons. So that is one of the answers for 8. You could also simplify this. So you could say like just 1 mole of aluminum solid is equivalent to 1 mole of aluminum ion plus 3 electrons, but either one works. Number 9, state the direction of electron flow through the wire when the switch is closed. So electron flow flows from the anode to the cathode. So in our case, the anode is just the aluminum, and that's where electrons are lost. And so the electrons will just go like this, so left to right. So boom. All right, number 10, explain in terms of Ag atoms and Ag ions why the mass of the silver electrode decreases as the cell operates. Well, pretty similar situation here, except we have a power source, right? So this is a electrolytic cell right here. So Ag is our anode, all right? So that's going to be oxidized. So when we oxidize it, it's going to lose electrons. And like we talked about before, if you lose electrons, you're going to be losing mass as well. So boom. Number 11, state the purpose of the power source in the cell. Well, the power source is really what drives this reaction. So the purpose of this power source, or in our case, I'm assuming it's a battery here, is to drive the spontaneous reaction. So boom. All right, number 12, identify the cathode in the cell. Well, we kind of did that because we said it starts in the anode with the argon, and then we end on the other side, which in our case would just be nickel. Right, so our nickel solid is going to be the cathode. So the nickel key. All right, so that does it for the redox reactions review. If you guys learned something, make sure you subscribe, and thank you for watching.